Hey there, pre-calc people. Today we are looking at 2.14 actual modeling, live action stuff. All right. We're going to do a bunch of vocab you guys can read, so I don't want to spend a lot of time in class on this, but 3 spots where this is used a lot are with Richter scale modeling, where your Richter scale is log of x over your initial x, which is going to be 10 to the negative third. 0.001 millimeters, if you want to do it that way, 0.0001. Your pH scale is negative log of H plus, where that's the concentration of hydrogen ions. And we've seen that one before. It goes from 0 to 14. And Newton's law of cooling, where the temperature of an object is equal to the temperature of the surrounding medium plus the temperature of the initial minus the temperature of the surrounding medium times e to the negative kt, where k is the constant for the thing we're looking at. Let's do some examples. But these formulas come up a lot. I'm pretty confident they're going to give them to you, so we just have to know how to use them. All right. So example 1. Go back and read those again too if you need to, or they're in your packet. A satellite is launched from a spacecraft and will reach a stable orbit of 300 kilometers above the Earth if it reaches a velocity of 7.7 kilometers per second. The rocket has a mass ratio R of 26, an exhaust velocity of 2.85 kilometers per second, and firing time of 120 seconds. Use the formula for the maximum velocity t. Given this, determine whether satellite will achieve stable orbit over Earth. Okay. All right, let's do it. So the firing time, the rocket's going to fire for 120 seconds. So t is going to be 120 seconds. C, they tell us, is 2.85. Which makes, yeah. What else do we know? That 26. R is 26. All right. Do we have everything we need to plug into this equation to find our velocity? We do. And it needs to be at least 7.7 to get stable. So we're going to plug in V of our t, which is 120, equals negative 0.0098 times 120. I'm plugging in 120 for t, plus our c, which is 2.85, times natural log of r, which is 26. So I like to write out my variables. That helps me out. Now when I plug that in my calculator, I get 8.1095 kilometers per second. It's going to be my velocity, 120 seconds of firing time. All right. So what that means is that bigger than 7.7? Yes. So that means at some point it'll get 7.7. So yes, the satellite will reach a stable orbit. Getting emails. All right. All right. Let's do another one. Another one. I got to finish this soon. My next class is starting. All right, let's look at example 2. Example 2, we have an equation. A log of E is how much energy in ergs it has. A log of E equals 11.8 plus 1.5 times m, where m is my Richter scale that I measured. So how much energy was actually released? All right, so I want E, my ergs. So I'm going to do log of E equals 11.8 plus 1.5 times, what's my m? 7. It's my measure, 7.8. All right. So I get log of E equals 23.5. Now, how do I get rid of a log? They both have as a base of 10. So I take both as a power of 10. So my ergs, Jiminy Crickets, equals 10 to the 23.5 ergs. Okay? Okay. All right, last one. Let's do example 3. Call it a day. All right, so pH ranges from 0 to 14. 7 is neutral, and every level greater than that is basic, 10 times more basic, and everyone less. Remember our magnitudes? So apple juice has a pH of 3.49, and fat cream has a pH level of 6.62. What are their hydrogen ion concentrations? All right. So my apple juice has a pH, apple juice, AJ, is going to be log, what's our formula? Log of our H. So whatever the H is, H plus, equals 3.49. So to get rid of log, I take both as a power of 10. Or negative, that's a negative. So my H plus is going to be 10 to the negative 3.49. Sorry, I copied down the equation wrong. Ta-da! And that's moles per liter. Okay? So our whole fat cream is going to be what? Again, that's negative log H plus equals 6.62. Move over the negative. So I get 10 to the negative 6.62 moles per liter. All right. Let's do it. Let's work it backwards. All right. So if I'm given H plus, how do I find the pH? Well, I use my calculator and I log it. Negative log it, right? So I do negative log of that. I get 7.35, which is a base. It's bigger than 7. I negative log this number, and I get 3.44, which is an acid. I negative log this number. I'm just using the formula. And I get 7.1, which is a base. And I plug in this one, and I get 2.74, which is an acid. That's it. I got done right in the next time. All right, guys. I hope you enjoyed. Hope you have a good day. See you on the flip.